Welcome to Three Crowns Academy. My name is James Pearce. In this module, you will learn how to build a naive-based classifier to predict sentiment. The first thing you need to know about building classifiers is you need two things. One, you need a set of known variables, and two, you need a target. Now, known variables can be known as features, and the target can be known as a label or as a response. There are different words used in different contexts by different people. They're all the same sorts of things. The features that we're going to use are the TF-IDF scores for each of our 1 and 2 grams, plus the sentiment scores we calculated in our first classifier, so we're building on our knowledge. To do this, we're going to use scikit-learn's Multinomial NB classifier, and I encourage you to look up the help documentation in scikit-learn for that. This classifier is often used in natural language processing problems, and in our case we're going to use it because our target variable has 3 levels: positive, neutral and negative, and the Multinomial NB is a classifier that copes well with these multi-level target variables. It's also helpful for you to know how these classifiers work in scikit-learn. They're very similar to what we did before with transformers such as count vectorizer and TF-IDF vectorizer, except instead of the transform stage, now we predict. So we fit first, then we predict. And you can see here there are two different types of predictions. There's predict, which will predict the classes. So I'll get a column back with the class that I expect for each review. Or I can do predict underscore proba, and that will give me 3 columns, each with a probability of the review falling into each of these columns. So they should add up to 1, and I'll get a probability of positive, a probability of negative, and a probability of neutral. Now this is useful if I want to play around and find the best possible thresholds to say, well, if it's above 80%, then I'm going to say only these ones are positively positive sentiment, etc. I can play around with that and get the best fine-tuned classifier that I want. Now let's have a quick look at what's sitting in the notebook. So we go through reading the data as normal, creating a training sample, and we do some balancing of the training sample because the classifier is going to work better if we have roughly equal classes to go from. So then we go through, we build the classifier. I've got a little thing here just showing you that fit and predict sequence, so you can refer to that. On we go. I didn't tell you the name of this. It is 00.05 trainer classifier .ipynb, and then we go through, put in our sentiment calculation function, and so on. The next thing we do is kind of interesting, and this is something that scikit-learn lets you do, and that is it lets you use its pipeline class, and I'll show you how to do this in the notebook. And what that does is saying, instead of saying, well, we've got a pre-process with TF-IDF and then we've got to classify and we've got to keep track of that, then when it comes time to predict on a new data set, we've got to do those same 2 steps. What a pipeline lets us do is to combine those together into the one classifier. So now we've got a classifier, and all we have to do with this pipeline classifier, which combines our TF-IDF and our Multinomial NB, is fit that and then predict it, and the pipeline is handling the rest for us. Now I'll tell you a bit more about the naive Bayes classifier, or the algorithm really. It's an algorithm that uses the Bayes theorem with a naive assumption, and that is all the known variables are independent. Now this means that a change in one known variable is in no way associated with a change in another known variable. So with this assumption, we can assess each variable's contribution to predicting the target independently. And all of this makes calculating the weights for the algorithm like a gazillion times easier. However, in the real world, this assumption is almost never true. Variables are associated with each other all the time. And you know what? The classifier works as well as if the assumption were true. And now I've used this one in this example Scikit-learn has a swathe of other classifiers that you could use if you wanted to. And I encourage you, in fact, to go and find some that look at multiple levels and play around with those as well. See if you can make your classifier better. Remember, they all work the same. You fit, then you predict. I'm just going to pop back into the notebook here. And one last thing that I do in here, which is searching for the best classifier. Another thing I can do with a pipeline now is optimize that pipeline and start playing around with some of the different parameters that I could have put in. So I can compare our new sentiment calculator with our old sentiment calculator. I can use count vectorizer versus TF-IDF vectorizer. And I do a bit of that in this notebook to see if I can make the scores a bit better. So you can go through, have a look at that, look at the results, see what comes out, have a look at some examples, and all of that is fantastic. And I'm sure you will enjoy that challenge. So then, once you've worked through the notebook, you will have come to the end of this little course of training your first sentiment classifier in Python. Thank you very much. Congratulations. So just to recap, you've learned to read the data into Python, explore the data, pre-process the data using counts, TF-IDF, regular expressions, n-grams, stop words, stemming, and lemmatization. You've built a word cloud, and you've built a classifier. Now you're ready to apply your sentiment classifier against other sets of documents. You can even build new classifiers, and you have all the tools you need to do this against any sort of corpus of documents that you can find out there. Your own comments from your own websites, your own documents, your own emails even. Whatever you like to do, you've got the tools in place to do it. Thank you very much. Thank you for learning with 3 Crowns Academy.